Welcome friends. Today we shall learn about one-dimensional collision and its basic theory. What is a collision means? A collision means when two or more particles interact with each other is known as collision. One-dimensional collision means it occurs along a particular axis, say either it is x-axis or y-axis. There are three types of collisions. One is perfectly elastic collision, one is perfectly inelastic collisions, and partially elastic collision. In inelastic collision, the momentum and kinetic energy does not conserve. There is loss of kinetic energy. Suppose two mud or clay ball stuck with each other and it becomes a one system after the collisions and goes with same velocity v. But today we shall discuss about one-dimensional elastic collision. We shall discuss about one-dimensional collision for elastic collision. What is elastic collision means? Elastic collision means the linear momentum as well as kinetic energy is conserved before collision and after collision. There is, in practical, there is nothing elastic collisions. Rather, we can assume that the collision between the nuclear particles like electron, proton collision is assumed to be elastic collisions. But in practical, there is not ideal elastic collisions. Today we shall discuss about the basic theory of one-dimensional elastic collisions. Let us consider two particles A and particle B. Particle A, particle B. Particle A and B are placed on ground. Particle A have mass m1 and velocity v1, whereas particle B has mass m2, velocity v2, and they moves along the same side, they moves along same position or same side. Now, before collision, V1 is greater than V2. That is, particle A moves with greater velocity than particle B. Now, if the velocity of A is greater than velocity B, what will occur? Collision will occur. After collision, the velocity of A is becomes v1 dash and velocity of B becomes v2 dash along the same direction. So, it is called one-dimensional collision. Now, if the linear momentum is conserved, then we can consider A and B as one system. We can write m1 v1, that is the product of mass of A and B, product of mass and velocity of A, plus m2 v2 is equal to m1 v1 dash plus m2 v2 dash. V1 dash and V2 dash are the velocity of particle A and B after collision respectively. So, we can get m1 v1 plus m2 v2 is equal to m1 v1 dash plus m2 v2 dash. We can say it equation number 1. Now, if we rearrange it, we can get m1 v1 minus m1 v1 dash is equal to m2 v2 dash minus m2 v2. We can take m1 in left side and m2 on right side for our is convenience of calculations. Therefore, if we take common of m1, we can get v1 minus v1 dash is equal to m2 v2 dash minus v2. This is equation number 2. This is the equation number 2. Now, as the collision is elastic, so the linear momentum is conserved and also the kinetic energy is also conserved. So, from kinetic energy conservations, we can get? We can get half m1 v1 square plus half m2 v2 square is equal to half m1 v1 dash square plus half of m2 v2 dash square. This is from the conservations of kinetic energy. As we can know, the expressions of kinetic energy is half mass in times velocity square. Now, we can also rearrange it. What can we get? We have to delete the picture because of low space in blackboard. So, if we can take from this, what we can get? The half will be cancelled from two sides. We can get m1 v1 square plus m2 v2 square is equal to m1 v1 dash square plus m2 v2 dash square. So, m1 v1 square minus v1 dash square is equal to m2 v2 dash square minus v2 square. We can take it equation 3. Now, if we divided equation 3 by equation 2, what we can get? This can be written as m1 a square minus b square, that is v1 plus v1 dash v1 minus v1 dash is equal to m2 v2 dash plus v2 into v2 dash minus v2. If we take this equation as 3, it will be more convenient. Now, divide equation 3 by equation 2. We can get m1, this term will be cancelled, m1 will be cancelled. We can only get v1 plus v1 dash is equal to v2 dash plus v2. This and this term, also this and this term will be cancelled. So, we can get v1 plus v1 dash is equal to v2 dash plus v2. Therefore, if we rearrange it, v1 minus v2 is equal to v2 dash minus v1 minus v2 is equal to v2 dash minus v1 dash. we can name it equation 4. Now, V1 minus V2 is the rate of separation between the particle before collision, and V2 dash minus V1 dash is the rate of separation between the particle after collisions. That is, V1 minus V2 is the velocity of separation V1 minus V2 is velocity of separation, or we can say it velocity of approach before collision. And V2 dash minus V1 is velocity of separation after collision. Velocity of approach before collision must be equal to the velocity of separation after collision, because when two particles comes to collide, the velocity of approach becomes smaller, it decreases their separations, and after collision the velocity of separation become increase, so it will separate more than more. So we can get from equation 4 V1 minus V2 is equal to V1 dash minus V2 dash minus V1 dash. Now, if we multiply this by equation 4 by M2 and subtract it from equation 1, remember equation 1? Equation 1 will be, what will be the equation 1? If you point it but note down, you can get M1 V1 plus M2 V2 is equal to M1 V1 dash plus M2 V2 dash. This was the equation 1. Now, if we multiply equation 4 by M2, this equation, and subtract it from equation 1, what will we can get? The velocity of V1 dash and V2 dash. Velocity of V1 dash and V2 dash in term of V1 and V2. What is V1 dash and what is V2 dash? V1 dash and V2 dash. We can get V1 dash is equal to M1 minus M2 by M1 plus M2 into V1 plus twice of M2 V2 by M1 plus M2. And V2 dash is equal to twice M1 V1 by M1 plus M2 minus M1 minus M2 by M1 plus M2 times V2. These two equations we can get by multiplying equation 4 by M2 and subtract it from equation 1. You can check it by doing rough on your exercise book. We can get these expressions, that is the velocity after collisions in terms of their initial velocities. You have to derive in, and also you can little remember it, for as there is no error in your calculation. So, we can get V1 dash equal to M1 minus M2 by M1 plus M2 into V1 plus 2M2 by M1 plus M2 into V2. V2 dash is equal to 2M1 V1 divided by M1 plus M2 minus of M1 minus M2 M1 plus M2 into V2. Note down, this is V1 dash. So, this in twice terms we can get V2, and for V2 dash in twice terms we can get V1. Now, special cases be occurred. It cannot be possible that the two particles will be same mass. Sometimes one is heavy and one is lighter. Now we can derive the velocity for a heavy and light particle. Number 1, if m1 much greater than m2, m1 is very heavy compared to the m2, then this term m1 minus m2 by m1 plus m2 nearly equal to 1. How it is possible? Because as m1 much greater than m2, so m2 is negligible compared to m1 and this is also negligible. So this will be m1 upon m1. So we can get 1 because m2 is negligible compared to m1. And what is the 2m2? This term 2m2 m1 plus m2, this will be 0 because m2 is negligible, and the remaining part, that is 2m1, if we take v1 side, 2m1 by m1 plus m2, that is 2m1 by m1 plus m2, that is if we neglect m2, then 2m1 by m1 nearly equal to 2. So we can get V2 dash is equal to this term 2m1 by m1 plus m2, 2m1 by m1 plus m2 is equal to 2v1 minus m1 minus m2 by m1 plus m2 equal to 1. So 2m1 minus 2v1 minus v2, and v1 dash is equal to m1 minus m2 by m1 plus m2. This is 1. v1 plus this term will be 2m2 by m1 plus m2 will be 0, that is v1 dash equal to only v1. What does this means? That is the v1, that is the first particle, heavier particle, will go almost unchanged velocity. The velocity of heavier particles will be unchanged. When a heavier particles collide with a light particles, the heavier particles velocity after collision will be the same as its initial velocity. And v2 dash, that is velocity of the light particles after collision, v2 dash, if it is rest before collisions, then v2 is equal to 0. If the lighter particle will be rest, then v2 dash equal to 2v1 minus v2. From this term we can get v2 dash is equal to 2v1, that is v2 dash will be equal twice of the heavier particle, and v1 dash equal to v1, that is same speed. তাহলে the velocity of lighter particle, lighter mass, and this is velocity of lighter mass of this v1 dash, and heavier mass is equal to, velocity of lighter mass equal to v2 dash, velocity of lighter mass equal to v2 dash, and velocity of heavier mass, So if a heavy mass collide a lighter mass, the velocity of heavier mass will remain unchanged, but the velocity of lighter mass equal to 2 into the velocity of heavier mass if it is rest initially. If it will have some velocities, then the expression will be another. Then the expression will be 2v1 minus v2. If it will be rest, then the expression is 2 into heavier particle, the velocity of heavier particles, minus v2. the velocity of it after collisions, the velocity of its initial velocity. So, we can easily get this. Now, if the case will be reversed, what will be occur? So, for case 2, if lighter particle strikes heavier particle at rest, that means heavier particle is at rest from behind. So, in this case M2 much greater than M1. If a lighter particle strikes a heavier particle which is at rest from behind it. So, for this M1 minus M2 by M1 plus M2, then the value of M1 minus M2 by M1 plus M2 will be nearly equal to M2 at M2 greater than M1 negligible, then nearly equal to minus 1, 2 M2 by M1 plus M2 nearly equal to 2 because M1 is negligible, and 2 M1 by M1 plus M2 nearly equal to 0. So, what will be V1 dash and V2 dash? What will be the V1 dash and V2 dash? So, V1 dash equal to what is V1 dash? Velocity of lighter particle. V1 dash. V1 dash means, V1 dash equal to M1 minus M2 by M1 plus M2 into V1 plus twice M2 by M1 plus M2 into V2. So, what will be V1 dash? V1 dash equal to M1 minus M2 by M1 plus M2. What is the value? M1 minus M2 by M1 plus minus 1. That is V1 dash equal to minus V1 plus this term is 0, 2M2 by M1 plus M2, 2M2 by M2 by M1 plus M2, this term is 2 V2 plus 2 V2, but we can say that this is will be rest. So, 0, that is V1 dash equal to minus V1. V1 dash equal to minus V1, and velocity of heavier particle V2 dash is equal to 2M1 by M1 plus M2. This is 0. So, 0 minus M1 minus M2 by M1 plus M2 minus 1, that is plus 1 V2, that is 0 plus 1 into V2 means V2. That is, the lighter particle will recoil with same velocity but in opposite direction, and the velocity of the heavier particle remains same. This is exactly the same case when a ball strikes a wall, recoil with same velocity, but the wall is rest and its velocity will be same. This is the condition of elastic condition in one dimensional motion. Now, if the mass, now we can get case 3, if M1 equal to M2, if the mass will be equal, then what we can get V1 dash equal to M1 minus M2 by M1 plus M2 times V1 plus twice M2 V2 by M1 plus M2, and V2 dash is equal to twice M1 V1 by M1 plus M2 minus M1 minus M2 divided by M1 plus M2 into V2. Now, if M1 is equal to M2, then this term will be 0, this term will be 0, and 2M2 by M1 plus M2 equal to 2M2, 2M2 by 2M2 V2, that is V1 dash equal to V2, and what is V2 dash? V2 dash equal to 2M1 by M1 plus M2, that is 2M1 by 2M1, if M1 equal to M2, then V2 dash equal to V1, V2 dash equal to V1 minus this term is 0. So, if they are equal mass, then V1 dash equal to V2 and V2 dash equal to V1, their velocity will be mutually interchange. So, this is the basic theory of elastic collision in one-dimensional motions. Here we can consider that three cases. If the heavier particle collide the lighter mass, heavier particle velocity will be same, but the lighter mass velocity is twice of the heavier particle. Number 2, if heavier particle is rest and lighter particle strikes, then velocity of heavier particle will be same and velocity of lighter particle will be same but in opposite direction, will be same but in opposite direction. And number 3, if they are equal masses, then velocity will be interchanged, that is the velocity of first particle will be the velocity of second particle and velocity of second particle will be the velocity of first particle, because V1 dash equal to V2, V2 is the velocity of second particle and V2 dash equal to V1, velocity of first particle, become velocity of second particle after collision equal to velocity of first particle before collision. So, you can understand the details theory of elastic collision in one-dimensional motion. Next day we will learn about the velocity of the collision of elastic collision in two-dimensional motion. Then we can solve some numericals of collisions. And please let me know that what topic you want to discuss. I can solve it for you, and the theory and numericals also will be given. Thank you for watching.